Hello, and welcome to the Linux command line video series. In this video, we will look at the basic commands needed to connect to a network. Please help me out by hitting the subscribe button so I can stay in my comfort zone. A networked device has several layers of identification. Let's start at the layer for us humans. We generally prefer to use names, so machines will usually have a host name. The host name is what humans use to connect to another machine. For example, when you want to look at a web page for a company, you would go to a browser and type https://www.linux.org. So in this example, www would be the host name of the machine you are trying to reach, and linux.org would be the domain name. To obtain the name of the system, we can use the hostname command. So we can just simply type hostname, and this will return the name of the machine. To change the name of a system, use the hostname command again to effect a temporary change. So we can say hostname space hilltop. And in this case, we'll get an error reminding us that this is a task that will require root privileges. So we need to use sudo. So let's do this again with sudo hostname hilltop. So now we can go ahead and type hostname again to verify the change. And as we can see, the machine is now called hilltop. And as I mentioned, this is only for a temporary change. If we reboot this machine right now, the hostname will be reset to the original, which is Kane. So in order to make it a permanent change, we can edit the file called /etc/hostname. So once we've made this change, upon the next reboot, the machine will be named Hilltop. And to check on the domain for your system, you can do hostname space -d. Another command to check on the domain name is domain name. Computers, on the other hand, doesn't really use host names, but rather they use an Internet Protocol address, or more commonly known as an IP address. To configure or view the current network settings, you can use the ifconfig command. So if we type in ifconfig and hit return, we see that the command will list all of the network interfaces for this device. In my case, I have ENP0S31F6, which is the Ethernet adapter, and also LO, which is the loopback device. For each interface, we see the IP4 address, the net mask, the IP6 address, and the MAC address. And lastly, the receiving and transmitting stats. IP addresses can be dynamically assigned or statically assigned. If you want to set your own IP, for example, if you are on an ad hoc network, you just need to shut down the interface, then add a new IP, and then turn that interface back up. So the way we can do that is sudo ifconfig, specify the interface ENP0S31F6, and then we're going to tell it to go down. Now we're going to do ifconfig to verify, and as you can see, that interface actually doesn't even come up because the interface is now shut down. Now we can do sudo ifconfig ENP0S31F6. We're going to tell it to go up with the IP address of 192.168.23.55. And we are going to set a net mask of 255.255.255.0. Now if we do ifconfig again to verify, we can see that the interface is back up, and the IP address that we gave it is now the IP4 address, and it's got the net mask that we gave it. Instead of self-assigning an IP address, if the network has a DHCP server running, you can use the dhclient command to request for an IP address to be assigned. So let's go ahead and unassign the IP for the Ethernet interface first by doing sudo ifconfig enp0s31f6, and we're going to use 0.0.0.0. Then we're going to use ifconfig to verify, so we can see that the IP4 is no longer set. So the next thing we can do is do sudo dhclient, and then specify the interface, which is enp0s31f6. And successful assignment of an IP address can be verified by typing ifconfig. Once a network device has been activated and an IP number is assigned, you can check connectivity to the network by using ping and traceroute to a known IP or computer name. Common usage of ping to test connectivity to another machine is basically ping and then the name of the machine, which in this case I'm going to do engineering.berkeley.edu. And then it's going to go reach out and send a ICMP echo request to that particular machine. And for the Linux version, this will go on forever unless you stop it. So to stop it, go ahead and hit Control-C. And you can also specify the -C option to do the count, so you don't have to do the Control-C. So once again, we can do ping-C, the number 4, to do only 4 pings, and then give it an IP number. So in this case, let's do 35.185.57.23. And note that sometimes you may not get a response even though that machine is actually up and running. And this could be because the firewall is set to block any ICMP echo requests. So keep in mind that just because a ping doesn't respond doesn't mean that machine is off. Another command you can use is traceroute, which will list the routing between you and the machine you are trying to reach. So a common usage of traceroute is traceroute. Let's do --resolv-hostnames, and then www.youtube.com. So the option resolv-hostnames will basically use hostnames if possible instead of IP numbers. And this traceroute command can help troubleshoot if your packets are stuck in some router between you and your target. In order to use a computer name as a target of the ping or traceroute or any other command, you must be using a domain name service, or DNS. DNS will translate a host name into an IP address that is needed for locating and identifying devices within the underlying network protocols. So if you are using dynamic IPs, the DHCP server may also provide the location of the name server for your DNS, and also the location of the default router. So let's take a look at our case here. We're going to do more of etc hosts. This is used for the first point of lookup for any host names prior to going out to a DNS server. So the contents of etc host basically points back to our local machine. And so it will try to use the local machine to resolve the DNS. To check if you have DNS configured, look at the file etc resolv.conf, which will tell you the IP of the name server or name servers that your machine will use for resolution. So if you can't reach a host by name, then for some reason the name is not resolved in your current DNS, you may want to add another DNS server. So we can go ahead and vi/etc resolv.conf and just add in name server 8.8.8.8. It's a popular name server as it's the free service from Google. And to test DNS name resolve, you can use the host command, which is going to translate the IP address for the name. So if we type in host engineering.berkeley.edu, this is going to give us the IP address of engineering.berkeley.edu. Once you have resolved a host name, your computer keeps track of the IP to MAC address data in a table called the Address Resolution Protocol, or ARP table. You can view this table by just typing the command ARP, or you can do arp-a to view it in the BSD style. So ARP basically just associates the 32-bit IP4 address to the 48-bit MAC address. And then it will also tell you what interface it was connected through. You can also type cat of proc/net/arp. This will also give you the ARP table. The ARP command could be useful when you're having network issues where you're not getting the expected response from a remote machine. This could either be an honest mistake where the system admin assigned two machines the same IP address, or else you could be the victim of ARP poisoning. The command netstat is used to see the network connections, routing tables, and interface stats. So there's many options to netstat, but here are some common ones that you may see. You can type netstat-ei. E is for the extended data, and I is for all interfaces. And you can see that this pretty much looks like the output of ifconfig, right? So for each one of the interfaces, it gives you all of the data, such as the IP addresses, net mask, broadcast address, MAC address, transmit and receive statistics, etc. Another example of using netstat is to do netstat-rn. So what this is going to do is show you the routing tables with numeric addresses. So here you can see that if you want to go to the 169.254.144.0 subnet, you're going to go through the interface of the Ethernet port. And basically everything else, you're going to go through the Wi-Fi interface. A port is a connection point for an internet protocol. Ports are associated with an IP address and a protocol, which is typically either the transmission control protocol, otherwise known as TCP, or the user datagram protocol, which is usually known as UDP. Ports are typically enumerated with a 16-bit number known as a port number. So 16-bit translates to 65,536 times 2, right? One for each one of the two protocols. So usually machines can have typically up to more than 13,000 ports that it is using to transmit data through. Certain port numbers are reserved for specific purposes. So for example, port 80 is typically reserved for the HTTP service. So for a list of services, you can look at the file /etc/services on your system, or you can go to http://www.iana.org/assignments/port numbers, and it will give you the typically used ports. And some other commonly reserved ports are port 21 for the FTP protocol, port 22 for Secure Shell or SSH, port 23 for Telnet, port 53 for Domain Name System, port 443 for Secure HTTP, otherwise known as HTTPS, port 445 for Server Message Block, otherwise known as SMB, or the Windows File Share Protocol. And to see the actively listening ports on your current system, you can use netstat by using netstat-4lntp. So this will give you all the IP4 related activity. The L is only going to show the listening ports. -N is going to show you the numeric addresses instead of the actual names. -T will only show you TCP activity. And -P will show you the PID and name of the program. And port 631 is the Internet Printing Protocol. You can also see it's listening on port 53, which is the DNS, port 3260, which is the iSCSI target, port 445, which is for the Microsoft File Share Protocol, the CIFS protocol. Port 139 is NetBIOS, and port 111 is the Sun RPC. So these are all the various ports that are listening on this particular system. We can also use the nmap command to scan ports for a system. So we can say nmap and then give it an IP number of 172.20.3.119. In this case, it's going to come back and say that this particular device, which is our local machine, right, it's named Hilltop. It is listening for port 25, which is the male SNTP. It's listening on 111 for RPC. It's listening on 139 for NetBIOS, and it's listening on 445 for the Microsoft Share, and 3260, which is iSCSI. Another usage for the nmap command is that we can actually scan a network. So if we do nmap-sn and give it the network address with the /24, so basically it's going to be in the entire subnet of 172.20.3. Basically everything. Yeah, so we're going to scan two separate networks, the 172 network and then the 169 network. So remember, we actually have two separate networks set up on this machine because we have the physical wired Ethernet interface, and we also have the wireless Wi-Fi interface. So both those interfaces will give us different results because they're on different networks. The IP tools is a newer tool set that is capable of showing and manipulating devices and routing. On some newer systems, you may encounter only the IP tools. On some older systems, the older package of net tools may be the only tools available. So it's a good idea to learn both sets of tools. So instead of using ifconfig to configure your network devices, you may have to use the IP command. So let's go ahead and look at the first example. The command that is equivalent to just ifconfig is IP space adder. Okay, what this is going to do is show you for all the interfaces the particular statistics of IP4 and IP6 addresses, routing, netmask, and so forth. And in order to use the IP command to add an IP4 address, you can do sudo IP adder add, and then give it the IP number 169.254.144.18/24, right? That's going to be the netmask equivalency of 255.255.255.0. And then we're going to specify a device, and that device is going to be our Ethernet, so ENP0S31F6. So once we do that, we can do IP adder to verify, and as you can see, it has now given a IP4 address to our Ethernet connection. Next example is if we want to bring the interface up or down, you can do sudo IP link and then set dev ENP0S31F6 and then up or down depending on what you're trying to do. And to see other systems on the network akin to nmap, you can use ipna, short for neighbor. And the substitute for the netstat command is iproute, which is going to show you the routing table. All right, so that brings us to the end of this video where we learned about basic networking commands. We used the hostname command to show the machine name. We used the ifconfig and IP commands to show and set network configurations. Then we used the ping and traceroute commands to test the network connection. We also looked at ARP, netstat, and nmap commands to view network-related information. Hope you enjoyed it, and if so, click on the thumbs up icon to like this video. Please hit the subscribe button to get notified when the next video comes out. Also, please leave me messages in the comment section below so I know what you liked and didn't like, or what you may want to see in future videos. See you next time.